In this video, this is going to be part 1 of the restoration on this Yamaha CR-820 Stereo receiver. And originally why I say it's a restoration, not just a repair, because originally a customer brought it in just wanting to get it repaired because he said he got no audio and none of the lights wouldn't work and stuff like that. And sure enough, it blew the 4-amp fuse right there, which goes to the amplifier section. So I went ahead and did further testing and found pretty much every single one of these drivers are blown, like literally. And that's kind of to be expected, because when the pre-driver goes, it will take the driver out with it too as well. So that's what happened, but took it out on both channels, which is kind of odd because usually you get one or the other channel blown out. And then the thing I looked at also was that these were replaced before, so it's blown the outputs before. And he did say that his friend that had this receiver had this repaired recently, and that they did put drivers in and stuff like that, and that blew again. So kind of makes sense. He just replaced the drivers and never actually checked the bias current or anything like that on it. And sure enough, I went ahead and actually checked that, and yeah, it was way too high and out of control essentially. So I went ahead and did further testing and stuff like that. I found every single one of the emitters are bad. They're measuring, and I got one right on the meter right there, and you can see that that's 0.8 and it should be 0.47, and there's some measuring even an ohm, and so they're all over the place essentially. So like, I mean, just breathing on, and here's the emitter or one of them itself, and you can see that that's 0.47k, and you can see right there that ain't measuring that. And like I said, it's all over the place. Some of them measuring as high as an ohm even. So those are all faulty. They got to get changed out. I also went ahead and checked the flame-proof resistors, which are these two white ones right here, one for each channel. Those are also open. They're all out. They're no longer resistors anymore. They're supposed to be 0.68. They're not. So those are no good. Those are going to get changed out. I went ahead and also found other problems. And you can see right there, those are some of the MPN transistors I pull. Even the PNP ones were like that too. You can see this black on the lead there. That used to be the silver coating. And they used to do the silver coating back in the day when they were making these transistors. And they put that silver coating because they figured it would conduct better and stuff like that. Unfortunately, over the years, that silver coating ends up oxidizing. When they oxidize, it works its way into the package, and then you start getting lower gain. You also get pop and crackle and stuff like that. That's when you know that they're actually failing and stuff like that. So I went ahead and changed those out. You do want to make sure when you change them out, of course, and substitute them in, that you do get the orientation right, where you get the base emitter collector in the right spot and stuff. So I went ahead and did that and changed most of those out already. I'm going to go ahead and pull next the diodes and stuff, check those out and replace as necessary and stuff. And then we're going to change all the emitters and stuff like that as well, including these two trim pods for adjusting the bias and stuff. Those are going to get changed out as well. So yeah, this is going to be a full restoration because I'm doing recap everything. It's getting everything new. You can see there I already changed those because on this side, one of these was shorted. So I went ahead and replaced both of them. So they're both changed on both channels, and yes, they are matching because I did match them. And same thing when I go ahead and replace the drivers, I'm also going to get a match set too as well when I throw them back in there. But before we throw new drivers in it, because you don't want to just go and put new drivers like the last guy did, because guess what's going to happen? It will blow them again. So you do want to make sure that, you know, you repair the amplifier section, of course, down here first before you go and put new output section on there. Make sure you turn your bias current all the way down, so when you go ahead and set your bias, you're not immediately going to blow your drivers and stuff like that. And I'll show you that once I get the new drivers, because I went ahead and ordered them up, and they should be coming hopefully in a week or so. And once I get the rest of the parts, the emitter and stuff like that, I'll show you how to actually adjust the bias, what the bias should be adjusted at, and how to check the offset and everything else. Because that's very important when you go ahead and put new drivers and everything else like that. You want to set the bias and you want to check the offset to make sure that there's not much, you know, deviation between the two channels, that you want to keep that millivolts very low from each other and stuff. And I'll show you how to check that later on. But I mean, now you can see there, I went ahead and also started recapping the power supply as well, because that was another problem I found a lot of these older caps here, and let me see if I can actually see one more. You can see one through that bag right there, and see how you got that stuff on the bottom. They started leaking out from the bottom, and not only that too, when I was testing them, some of the ESR values and stuff were way out, so I went ahead and just changed them all essentially. I'm also going to change the two main filter caps, and for that I'm going to have to do a modification, because you can see there, these are a lot taller than the new ones that are going. I'm also going to have to drill holes in the PCB right here, because even though these look like multi-lug, they're only like one negative and one positive, and the other two are used for holding down the capacitors. So essentially I'm going to figure out how that's going to go in right there, and then the bracket I'm going to have to bring down a little bit more once I bring that bracket down, so that way it can look factory essentially. We'll work on that, but the reason why I'm changing these out, because I got one hooked up to an ESR meter right here, and even on my LCR meter, which is more accurate, it measures quite low. Now that's actually measuring better than what it did the other day. Let's just check the other one. One of them was measuring even half the rating. So we'll go ahead and do that, and this should be positive right here. Yeah, you can tell. And typically you'll get a reading if you do it a couple times, and there you go. They're faulty. They're no good. You know, they're about 30-40% down, so those are no good. Here's the new ones that I'm going to put in, so we'll go and put one of the new ones on there. You can see that's much better, so those are going in there. We're also going to do all the fuse. I already took the relay apart, cleaned that out, cleaned the contactors and stuff like that. And then once we get the amplifier section sorted, then we'll go and worry about the tuner. Even though the tuner does actually work on this, there's nothing wrong with the tuner or the preamplifier. The problems were in the amplifier section itself. So that's going to be done, and once I get done, I'll do a second part once I get all the rest of the parts that I need for the amplifier to get that working, and I'll show you how to adjust it. And then the very next thing is having to deal with this goofy LEDs, I mean not LED, but lamp system that they got going on there, which we are going to be replacing them with LEDs, but I'll explain why that's the way they kind of got this wired kind of silly in a way, because if one goes out, they all go out essentially, but we'll work about that on the next part, and then we'll address the tuner and preamp section. But this is part one of the restoration on this Yamaha CR-820. Hopefully in a week or two I'll get the emitters, I'll get the rest of the diodes, everything that I need to get this amplifier section sorted, and then hopefully we'll be able to put the new drivers in there, set the bias and everything like that, and we get both channels pretty closely matched. So there you go, and this concludes the video for this for now. So I went ahead and put the test leads on one of those flame-proof fusible resistors, and that's 68 ohms in value. It's not 0.68 like I said earlier. It's actually 68 ohms for those that want to know. And let me see if I can get closer right there. And yeah, that's what it looks like. And then there's one on this channel right over here. And let me, of course, put the lead back on there, because we're not going to measure anything. Okay. And you can see there, it measures pretty much open and out of circuit. It does measure completely open, so that's no good, of course. So we're going to have to change those two out as well. I'm also going to go in and start lifting the legs on the diodes and testing the diodes and stuff, but I am going to substitute all the diodes in this thing as well. Might as well go ahead and do that. And then here's the original fuse that he had in there, and you can see there it blew in there, and I noticed he didn't even have the, hold on, let me see if I can get the markings there. Give me a second. It's only a 2 amp, and there you go, and you can see there it's supposed to be a 4 amp. So once I get the rest of the part in there, there'll be a second part of the video, and hopefully we'll get the amplifier section going fully. And that's the thing when you're repairing these amplifiers, if you have one component like that was shorted, you can see that got cooked too as well. When one thing fails, it is common to have a cascade of failures, because essentially then everything upstream is going to fail, then they're also going to take the emitters out. That's why they kind of probably drifted out and stuff, because they typically fail that way, where they'll go higher in resistance to eventually they open up, and sometimes they'll even flame out and stuff like that. So that's the thing when working on an amplifier and stuff. Typically one failure will cause a cascade of failures, and that's what happened in this case here. So like I said, once I get the parts in, we'll go ahead and work on the second part of this video. So one of the modifications I'm going to be doing is tying these two boards essentially together, because it relies on this brace right here that goes in there and stuff. And that's known to be problematic and stuff like that. This here is a dual rail power supply, and I'll have to explain how that actually works and stuff, and the reason why I'm going to be doing some of the modifications to kind of fix this. But either way it goes, that's one of the things we're going to go into in the next video. And then of course we'll go into this protection circuit too as well and stuff like that. But mainly it's going to be on how this dual rail supply actually works, the grounding points and stuff like that, and also on this protection circuit will be covered in the next video and stuff like that, and the problems that's related to this protection circuitry and so forth.